All right, here we go. Good morning and welcome back to my stream. Glad you're here. And what we're going to do today, let's switch over here, is we're taking a little break from the roguelike. Roguelike should return next week. This week, well, I don't know how long it's going to take, but this week I want to do the Rustlings. So Rustling, let me grab that URL I put on my channel thing. Darks. Okay, so here's Rustlings, and it is basically a tutorial for Rust. And a couple of years ago, I started this, and I never finished it. And I thought, well, they just released Rustlings 5.0.0, and it would be nice to give that a shot. See what it's like. This is to upgrade. So let's see if we can set up a nice little working environment here. What we got? This. Let's create a new window because I think these exercises are all pretty small. So I can zoom in a bunch, make a nice big font. Maybe just do this. And let's see how we can let's see how we can set things up before we get going. Oh, and let me pop up my chat before I forget. There we go. Okay, so Rustlings 5.0.0, probably Rustlings' biggest release yet. Let's see, how do we grab this? Installing it manually. Cargo install force path. Find out the latest version. Okay. Yeah, we can do this. So git clone. Right, let's go over here. Documents. Oops, my keyboard's not quite in the right position. Gotta be comfortable here. Documents. Dev. This is where I have all my stuff. Why depth 1? I don't know why depth 1, but let's do it. You're in detached head state. You can look around, make experimental changes, and commit them, and you can discard any commits you make in the state without impacting your branches by switching back to a branch. If you do want to create a new branch and retain commits you create, you may do so now or later by using -C with the switch command, or undo this operation. Turn off this advice by setting configurable advice detached head to false. I don't know enough about Git to know if this means anything. I'm assuming. Oh, I see. You can install dot. Okay, well, let's see. I think it just means that I can change things and not worry about what do we got here. Okay, let's take a look at install. Just see what script we're running. This looks all reasonable. Don't want to install a crypto miner. I'm not sure what this is doing. It's getting some version information. Function that compares two versions. Okay. How long is this? Oh, that's not bad. Right, but we can just run this by hand, so we don't have to go through that install script. I need to understand how install dot works, because it's obviously doing. How does it work? Right, because we have the source. Maybe it's building an executable. Let's find out what's in source. That gets installed in the .cargo directory. Yeah, there's a main. Okay, so maybe this is what's running. Right. What are they using for Command line parser from args. Arg. That's funny. Okay. All right. So this must be it. Okay, it's installed. And then how do we run it? Getting installed. Getting started. Run on REPL. Stop update doing exercise. Rustlings watch. The exercises are sorted by topic and can be found in the subdirectory, whatever. For every topic, there's a digital README file with some resources to get you started on the topic. We really recommend that you have a look at them before you start. Okay. The task is simple. Most exercises contain an error that keeps them from compiling, and it's up to you to fix it. Some exercises are also run as tests, but Rustlings handles them all the same. Run the exercise in the recommended order. Execute Rustlings watch. This will try to verify the completion of every exercise in predetermined order. It will also rerun automatically every time you change a file. If you only want to run it once, you can do Rustlings verify. This will do the same as watch, but it'll quit after running. In case you want to go by your own order, you can, or verify a single exercise, you can do that. Or simply use the following command to run the next unsolved exercise in the course. In case you get stuck, you can run the following command to get a hint. You can also get the hint for your next unsolved. You can check your progress, you can run the following command. Alright, so it must have installed the Rustlings command, right? Yeah, okay. So let's see if we can, let's see how this runs. Let's say the recommended Rustlings watch. Run the exercises in the recommended order. Run the Rustlings watch. Okay, Rustlings watch. The code is compiling. Source for this exercise is here. Have a look. You can keep working on this exercise or jump to the next one by removing I am not done. I thought you could, this popped you into an editor. Welcome to watch mode. You can type help to get an overview of the commands. Get a hint. Get a screen. Quits watch mode and displays this help message. Watch mode automatically, right, okay. Hint. Remove the I am not done comment in this file. Okay, so maybe I set this up in a separate, let's do a quit. Let's run tmux so we can have a couple of windows. We can put Rustlings watch, Rustlings watch here. Okay. That's going to be a little annoying if it's going to need to be a if it's going to get big. All right, but then I can just edit this file and delete the I am not done. Right. Oh, okay, so now we're in intro 2. I got it. So we just finished intro 1. So intro 2 is, let's just edit intro 2. What's it asking us to do? Add a positional parameter? Maybe? Cargo check's not going to really work for it, right? Because the main is not this. So, but it's a handy way for me to hit save. So even though it's running cargo check uselessly. All right, so this worked. Intro 2 worked. Next is variables 1. Yep. What do we need to do here? Not found in the scope. Oh, okay, just missing a let statement. These are easy. Yeah, so this is just still the intro stuff. It would be nice if they had like a test out of intro or something like that. So the next one is variables 2. Consider giving X a type. Well, we're going to compare it to 10. We can't just give it a type. We actually have to give it a value, right? And then it'll compare it. So that giving X a type wouldn't solve it, right? Because I could say I32, but then it'll say read before initialized. Use of possibly uninitialized x. Definitely uninitialized x, right? So we're going to leave it as x equals 10. All right, so then what's next? Variables 3. Okay, yeah, so we gave it a type, but we didn't give it a value. So we can just give it 10. Good. Okay, so yeah, these first few are going to be straightforward, I guess. This is variables 4. Let x equals 3, print x. Don't change this line. Oh, this is just saying we need to mutate it. Or make it mutable. Yeah, okay. So this is variables 5. And there's 2 errors here. Oop. Mismatched variables. Okay. Oops. Let's see. Number is 3. Spell a number. Number is 3. Don't rename this variable. And don't change this line. So it's just showing shadowing, I think. Yeah, okay. Just shadowing. Not bad. Next up is variable 6. Const number equals 3. So this is where we have to give consts a type. Right? Yep. Not bad. Call me, not found in the scope. So this is functions 1. So I could just delete the line and then it'll build. Right? But they probably want to create a function. Is that the intent? Oop, fun. Yeah, I mean, either way, right? But I guess deleting code is not the point of this thing. The point is to add code or modify existing code until you get it working. All right, fun 2. Call me 3. Call me num is missing an argument type. So we can just give it the old I32. Yep, not bad. Next is functions 3. What do we got? I wonder if I should split these vertically instead of horizontally. Because that'll give me more space here. Yeah, let's do that. And there might be actually a way to do that in Tmux. But I was thinking, well, I'll just quit the 2 things and then re-split everything. But Tmux, change from horizontal to vertical. Look at that. Somebody else has. Back in 2012, back in the olden days, Control B space cycles through available layouts. Oh, perfect. Okay. Yeah, this is better because we don't need that much horizontal space. All right, so we are now in functions 3. Functions 3, yes. Very good. Expected 1 argument, so 3. Right. There we go. So let's delete that. And what's up next? Functions 4, expected a type. Let's see, sale price is even, price minus 10. So it's just expecting an I32 in return. The store is having a sale where if the price is an even number, you get 10 Rustbucks off. But if it's not a number, it's 3 Rustbucks off. Don't worry about the function bodies themselves. We're only interested in the signatures for now. Okay. Yeah, so all we have to do is that, right? Okay? button 5. Expected I32 found. Oh, yeah, it's got an extra semicolon there. Okay. I am done. Now we're up to if 1. Now we get if statements. Complete this function to return the bigger number. Do not use another function call or additional variables. And all we're trying to see is if A is greater than B. So we can just say, oops, if A is greater than B, return A, else return B. Except you got to spell else correctly. Yep. Let's see if that works. Yeah. Okay, that wasn't too bad. If 2. Step 1, make me compile. Step 2, get the bar for fuzz and default to Baz tests passing. All right, so the first problem is that we're returning without even looking at the test, we can see we're returning a string and a number, and we're expecting a string. So can we just returning foo? We can just say bar here, just to return a string, and then we can take a look at the tests. Because step 1 is make me compile. So now it compiles, but we have a failing test, default to Baz. Default to Baz. Okay, so foo for fizz means if we pass in fizz, we get foo. Bar for fuzz means if we pass in fuzz, we get, oh, we have to pass, I see. I got it. So it's just else if fizz-ish is equal to fuzz, then return bar, and then default for Baz. That's pretty easy. Yep. Done. Now we're on quiz 1. And this is like not in a subdirectory. So is this like a major quiz thing? This is a quiz for the following section: variables, functions, and if. Mary is buying apples. 1 apple usually costs 2 rust bucks. But the comma should be here. If we're going to be technical, if you buy more than 40 at once, each apple only costs 1. Write a function that calculates the price of an order of apples given the quantity bought. No hints this time. Put your function here. Then calculate price of apples. Okay, so we just have to say if it's more than 40, right? Then each apple is 1, otherwise each apple is 2. So we can just take in apples. And since we've been using I32s this whole time, let's just use I32s. And so if apples greater than 40, more than 40, then return apples. Otherwise, return apples times 2. 2 rust bucks per apple. That should do the trick. Let's find out. Yay! Okay. Quiz 1 passed. Should I have done this as a speed run or something? All right. Next we have primitive types. Prim 1. These should be pretty straightforward, right? Because we're just doing primitive. Let finish the rest of this line like the example, or make it false. Or make it be false. We could just is evening. It's false. Is that what they mean? No hints. There's no tricks. Just get used to typing these. Okay. Hopefully it's not too tricky, right? Prim 2. Fill in the rest of the line that just has code missing. No hints. There's no tricks. Okay. What are we missing here? Oh, the let statement. Try a letter, try a number, try a special character, try a character from a different language than your own. Try an emoji. Okay, we can try a letter from a language other than my own. Character. There. Umlaut U. And what do we got? And I failed already. Is alphabetic is not found in str. Oh. Oh, it has to be a character. That's where I messed up. I have my first failure on primitive 2. There you go. All right. What's the next one? This is primitive 3. Let A equals something. Create an array with at least 100 elements in it where question mark is. I can just use the vec macro, right? Right? I mean, is that all they're looking for? Oh, yeah. Okay. That's all it is. Okay. Next. Primitive 4. Slice out of the array. Nice slice. So we're just going to slice 2, 3, and 4. And I've forgotten slice syntax already. 1.3. 1.4. Huh, okay, that's it. Come on, delete. Thank you. Next up is primitive 5. Let cat equals Furry McPherson. 3.5. Let something use your pattern here equals cat. Just structure the cat tuple so the println will work. Okay, so we're looking for name and age. Not bad. Primitive 6. What do we got here? Use a tuple index to access the second element of numbers. Okay. So the second element of numbers is .1. No, Rust format automatically move that up there for me. Okay. Maybe we submit a PR. Okay, so now we're in Vex 1. To do, declare your vector here with the macro of 4 vectors. Your task is to create a vec which holds the exact same elements as an array A. Oh, it's just, okay, it's just using the vec bang. Right? Is that all they're saying? And then we're going to compare the array and the vec? Yeah, okay. All done there. Vex 2. Ooh, this is a little more complicated. A vec of even numbers is given. Nice use of passive voice. Your task is to complete the loop so that each number in the vec is multiplied by 2. Make me pass the test. All right, so we're iterating mutably over the vec. So we can just say star I times equals 2. Right? That's all we need to do there. At this point, v should be equal to 4, 8, 12, 16, 20. Right? Is that all we need to do? Oh, there's 2 of them. Vec map. Okay, so now we're going to be mapping here, and we're going to do the same thing as above, but instead of mutating the vec, you can just return the new number. Okay. Yeah, that's not too bad. Learning how to use vecs. Move semantics. What do we got? Why is this not wrapping for me here? Oh, there wasn't anything there. Okay. So what's the error? We have consider changing this to mutable. Cannot borrow is mutable. So it's just Well, the Rust compiler is suggesting do this. Is this all we need to do? Yeah. Okay. Because all we're doing is, so let's see, is creating a new vector that's empty. We're saying fill vec, starting with vec 0, I guess. Does this create a copy of the input vec? It must do, because this is immutable, and then this just pushes onto the new vec here. Okay. All right, let's move semantics. Move semantics 1. So here's move 2. Yep. Do not change the following line. Make me compile without changing line 13 or moving line 10. So what's line 13 is that, and line 10 is that. Right, yeah, if I move this down to here, then, because we don't use it here. All right, so the idea is we're trying to learn how this move stuff works. What we can do, I guess, is just borrow it here. Will that solve the problem? Nope. Oh, because we're returning, so we have vec clone. Yeah, okay, that works. I don't know if that's the answer that they were looking for. Let's find out. So vec 0 is passed into fill vec function's argument. In Rust, when an argument is passed to a function and it's not explicitly returned, you can't use the original variable anymore. Ah, we call this moving a variable. Yeah, make fill vec borrow its argument. Make another separate version of the data that's in vec 0 and pass that. Make fill vec mutably borrow a reference to its argument, which will need to be mutable. All right. Well, we did number 2. Okay. Done. Oh, yep. So we have move 3. Make me compile without adding new lines, just changing existing lines. No lines with multiple semicolons necessary. Oh, that would be cheating, right? What's the error here? Can't borrow as mutable. So this is, oh, I see. So do we want to do this and then do this? This time we're looking at vec 1 here and vec 1 here. Try the conversion to vec. Isn't this already a vec? Oh, I don't have my compilation thing working. Oh, so it's expected vec and it found a mutable vec. Okay. So if we just 2vec it, I don't know if this is the answer they're looking for either. Let's find out. Difference between this one and the previous one is that the first line of fill vec had that let mut vec is no longer there. You can, instead of adding that line back, add mut in one place. That will change an existing binding to be a mutable binding instead of an immutable one. It's in one place. So I should be able to undo out of all that and change one place. Really? Okay, that's a puzzling thing. I can put a mute here, but we're passing it in immutably. One place. Really? And I can't pass this in mutably because vec 0 is immutable, right? I really think it's only one spot. This has to be mutable because we're going to push 88 here. Huh. Oh, you hint unknown. Add mute in one place that will change an existing binding to be mutable binding instead of an immutable one. Smiley face. That's very nice. I can't. No. Really? No. No. Yeah, I didn't think so. Mute on an argument. Yeah, that's what I just tried. Oh, you mean over here? Huh. Thank you, Shrishak. I didn't think you could do that because this is not mutable, right? So if you're passing in vec0, an immutable vec0, you're getting, is this providing you a brand new vec then? It's moving it in and making it mutable, maybe? Okay. And we're not using vec0 here anymore. We used to. The previous exercise had vec0 here. So Shrishak says, I just consider let as bindings, so it makes sense to me. Oh, okay. So it's the equivalent of having done a let mut vec equals vec here. Okay. I'm done. I just learned something new. All right, and this is move 4. Okay. Fill vec no longer takes vec as an argument. That's true. Refactor this code so that instead of passing vec0 into fill vec function, the vector gets created in the function itself and passed back to the main function. So it means we can't pass it in here. Oh, can't infer type? Oh, now we can't infer the type up here either. Because we're not passing it in. I assume that's what they're looking for. Get rid of the first line in the main that creates a new vector. Oh, yeah, we could just delete it. Yeah, okay. I got the equivalent going here. That's fine. All right, next is move 5. Make me compile by only by reordering the lines in main, but without adding, changing, or removing any of them. Let's see, mut x equals 100. Y is a reference. Oh, okay. Yeah, we can't have two mutable borrows. But if we do it this way, we drop y because there's no more references to y. And then we can drop z before we do this. Okay, so it was just flipping those two lines around? Yep. Okay, very good. Move 6. So data equals Rust is great to string. Get char data, which gets the last character. This says should not take ownership. You can't change anything except adding or removing references. Okay. So if we make this borrow data, then data down here is getting a reference. I guess we can flip it around, right? And just move it in since we're not using data anymore. course, it can't be a reference anymore. There we go. Yeah, so it was just adding reference to this one and removing the reference from this guy. Not bad. What's up next? Ooh. Oops. Oh, this one has a lot. Oh. The clear didn't completely clear it. We have greens and reds, and so this is Structs 1. Okay. Address all the to-dos to make the tests pass. Color classic struct. Something goes here. Color tuple struct. Something goes here. Instantiate a classic C struct. So it just should have red, green, and blue. Sri Shack says, how many exercises are there? Looks like fun. I think is based on this, it's 92 of them. But if you want to do these yourself, maybe don't watch my stream. That's a terrible thing for a streamer to say, right? Don't watch my stream. Because I'm going to go through as many as I can. And it looks like I'm almost, I'm getting close to halfway, about a little over a third of the way, right? Based on these numbers. And it's taken me a half hour. So I expect, depending on how hard they get as they go on, I probably will finish them. So it looks like we need a red, green, and blue. So I don't know what variable type. I guess we can make them, if they're colors, they should be U8s, right? It doesn't matter. Red, U8, green, U8, and blue U8. Nope. There we go. And then we're going to make a tuple, which I guess is just U8, U8, U8. And then we're going to say let green is equal to color classic struct. Red 0, green 255, blue 0. Right? And then tuple structs, we're going to say let green equals color tuple struct 0, 255, 0. And then instantiate a unit like struct. They're just saying do this. I guess. Let's find out. Nope, I failed one. Oh, this should be unit like structs are fun. Oh, I have to instantiate. Oh, okay. Right? I think that's all they're looking for. Yes, okay. And we're done with that. Now we have orders. Okay, this is Structs 2. Address all the to-dos to make the tests pass. We have an order. We have a create order template. And then we have your order. Order template is create order template. To do, create your own order using the update syntax and template above. Okay. So we can just say order. Right, we're using the update syntax, which is going to be order template, right? And then we need to change what's going to change here. So everything except for, so by default the count is 0, and by default the name is Bob. So we can just do this, right? Name is string from Hacker and Rust, and count is 1. And then fill in the rest from order template. I think that's what they're looking for. We just got a lot of errors because yeah, the entire struct didn't exist at the time. Okay. That wasn't too bad. Shishak says, shouldn't you do that below order template? Oh, the count? I don't think the order matters. I think you can initialize things in any order. And I think the for the update syntax, I think it has to be the last one. Yeah. It says help remove the comma because it has to be the last one, and of course that's going to fail because count isn't expected. Yeah, I think you can update structs in any order, or create structs in any order. Like if I move name down there, it still works. And yeah, except for this update syntax where you have to use this has to be the last one. I usually just do like default here, right? That's the way I normally use the update syntax. I don't typically do it this way, but this works. But maybe they just wanted to teach default later. All right, so this is Structs 3. Structs contain data, but can also have logic. In this exercise, we have defined a package struct and we want to test some logic attached to it. Okay, make the code compile and the tests pass. Okay, so is international and get fees. All right, so is international looks like it's returning a bool. Let's find out. Assert package is international. Okay. So have it return a bool, and package is simple. It has a sender country and a recipient country. Right? So all we need to do is say self.sender country is not equal to self.recipient country, right? That's is international. Yeah. And now get fees, cents per gram 4,500. Does it say what? Oh, I see. We pass in the cents per gram here. And then we just multiply the number of grams. Okay. So self weight in grams times cents per gram. Oh, I forgot to say it returns an I32. Yeah. Okay. That was easy. Well, not as easy as some, but there you go. Test 34. Change color. Oh, now we have enum variants. Enum 1. Enum message. To do, define a few types of messages as used below. Okay, so we're just creating these guys. Right? Like that. Is that all we need to do? Looks good. Why doesn't... I thought that when we print out our enum variants, it got the... I guess it doesn't do the whole path. Okay. And now we have enums 2. Message. To do. Define the different variants used below. Oh, okay. So we're just showing that enums can have different types. So we have a move, which takes an X. I guess we're still using I32s and Y32. We have an echo, which takes a string. We have a change color, which takes a U8, and a... Why am I putting periods there? U8, comma, U8. And then quit. Doesn't take anything. Yeah, okay. That's straightforward. Next up is Enums 3. To do, implement the message variant types based on their usage below. So where are we using message? We have point, we have a point structure and a state structure. To do, create a match expression to process the different message variants. Okay, so here's where we use it. State process. So we're calling this function to process it. I guess it's doing something with it. Oh, I see. We're mutating state here with all of this information, and then we're just checking to see if it's set. That makes sense. Okay. So we're going to process a message, and it's going to take... let's go back up here. We have change color, which takes the U8s, right? We have an echo, which takes a string. This is the same as before. Move, which takes, so this is slightly different. This takes a point, and then we have quit. All right, so we've defined the message types now. Oh. Expected 3 arguments, supplied 1 argument. Is this a this instead? Yeah, okay. So now we just need to implement process. And it says you create a match expression. Okay, so match. Let's grab these guys. Match self. And we're going to have message change color, move, echo, move, and quit. And this will do this, and this, and this, and this. And then instead of string, we'll do S. We have point, and we have C. And there. Okay, so now we have to just assign these guys. I guess we're supposed to call the function here. Self change color. C. Self echo C. S. Self move position P. And self quit. I think that's what it's looking for. Nope. Oh, not match self, match message. There we go. Yeah, okay. Not bad. That was a fun one. Enums 3. Okay, next up is strings 1. Okay. Make me compile without changing function signature. Okay, it's got a stir and it's returning a string, so we can just toString it. Just like the compiler says. Yep. Okay, that was easy. Next up is strings 2. Okay. Without changing the function signature. So it's passing in word. You can see as stir on this, I guess. Try not changing this line. Okay. There we go. Strings 3. Yep. Trim me. Remove white space from the end of the string. Compose me. Add world to the string. There are multiple ways to do this. Replace me. Replace cars in the string with balloons. Okay, well first what I can do is just get this to compile so we can see the tests. Failing. Right. Then we're going to, okay, let's see if we can get this to work. I think there's just input trim. Strong. from input trim. I think there's an input trim. I think there's a trim on stir. I'll have to look it up in a second. Oh, yeah, it is. Okay. Trim a string. Although I'm noticing now it says from the end of the string, and it's actually checking end and beginning and both. So let's make a note of that. What we can do is maybe submit a PR to fix that. Let's just go in here. Let's quit out of this. Notes.txt. And this is what strings 3. There's 3. Says end of text, or end of string maybe, but really wants both ends. Oh, maybe that's what they mean. Maybe, to me, end of string means just the right-hand side, and the start of string is the left-hand side. So, maybe this should just be from both ends of a string. All right, so we'll just save that as a possible thing to fix. Okay, now compose me, add world to the string. Well, I mean, that's pretty straightforward, right? Format bang, input world, right? Okay, so we got 2 of them passing and 1 failing. For this, I think there's a find. Let's go look. Rust. Oh, let's see. Yeah. Rust. What was it? Rust up? No, I forget what. There was a command to pull up the docs, and I can't remember what it is. Rust up docs. Standard. Something like that. Nope. All right. Rust stir string. You can see I've looked at this before. And is there a find? I don't see find here. Is there find in the stir side of things? Yes, I see R find, so there must be a find. Yeah. Rust up docs. Thank you. Yeah, there we go. Oh. Yeah, but there's an argument. You can give it like standard or something like that. Right? Yeah, there we go. And now I can just have it on offline instead of having to go over the network. So we were just in string. And we were looking at find. Actually, find. I can just do find on stir, right? And it returns an option usize. Epic Blog says, did not know that Rust up docs was a thing. Neither did I until yesterday. Somebody mentioned it on Togglebit's Discord. And I had just forgotten what the syntax was to pull that up. Yeah, and it just... I don't know if the docs are downloaded by default, or if there's something I did to get them here, but it's kind of neat. And it's all offline, so you don't have to... When you're on a transatlantic flight, you don't have to worry about not having them. So this returns an option usize. So we can do a find. What are we doing? Actually, we're replacing cars with balloons. So let's take a look here. So I think cars are cool should become I think balloons are cool. I love to look at cars should become I love to look at balloons. All right. So if we could do a find. While let sum found equals input find cars. Right, we can do that and then use a replace. Yeah, Shrishak says I think there's a replace method, and I agree. I think you're right. Oh, we can just replace the pattern directly. Replaces all matches of pattern with another string. Oh, I was going to make a little while loop, but that's even easier. What's this? This is old, this is new. This is old, S. Okay. All right. So it replaces all of them. So I can just say input string from input dot replace cars with balloons. I thought I'd have to loop, but I don't have to loop because the loop is built into input dot replace. Do I have this code? No. Oh, that's right. I don't have it set up this way yet. Okay. All right. So now we're in strings 4. Oh, now I have to guess. Okay, here's a bunch of values. Some are strings and some are strs. Your task is to call one of those two functions on each value depending on what you think each value is. That is, add either string slice or string before the parentheses on each line. If you're right, it will compile. So let's look for 3 question marks. And, oh, I tried change word, and that includes the open paren and the quote. Thank you, NeoVim. I guess we'll do it the hard way. Okay, so blue is a string. Sorry, string slice. This is a string. This is a string. To owned makes it a string, right? Nice weather into works either way, right? I'll say string. Oops. This is a string. These are all strings. This is a string slice because it's doing this little notation here. Oh, there. This is a string slice because it's doing it just a trim. Happy Monday, toString replace Monday with Tuesday. String maybe? My shift key is sticky to lowercase. String slice. Let's see how many I got wrong. I got 1 wrong. So to lowercase converts the string into this str into a string. Let me look that up now. It's too long to scroll through. Okay, to lowercase. Yeah, look at that. It's a stir method. It's a method on stir, but it returns a string. Since some characters can expand into multiple characters when changing the case, this function returns a string instead of modifying parameter in place. But why doesn't it just create a new stir? Maybe that's too hard. Okay, so I got 1 wrong. Nice. All right, that's stir. Sorry, that was strings 4. Now we're in modules 1. This is where everything falls apart for me because I still don't have a good mental model of how modules work. Ooh. Okay, Sausage Factory. Shrishak says creating a new stir means bad API because generally we can only read in stir. Okay. Yeah. Okay, yeah, and then string is just a new struct type. You can just allocate and return that. That makes sense. Don't let anybody outside this module see this. Get secret recipe. Oh, it's just a private function? Okay, so we just make that pub? Yeah, okay. We have module 2. Okay, fix these statements. So what are we looking to do here? We have mod fruits, which is got a pear and an apple. We have mod veggies, which is cucumber and carrot. And now we're looking for delicious snacks, fruit, and delicious snacks, veggie. So this must be this, right? They want to do this, fruit and veggie, right? I think that's what they're looking for. Shrishack says pub super to be specific. Okay, before I look at this, I'm going to go flip back here. What you're saying, this will also work? And if this says modules 2, yeah, this is doing modules 2 again, which means modules 1 worked. I don't know what the difference is between just plain old pub like that and pub super. So I know there's pub crate. And I don't know if that'll work in this instance. It does. It does. And plain old pub works also. Okay. I'll have to read up on pub super. All right, this doesn't work because this is a private constant import. So let's make them pub. There we go. I'm just going to try this out now because I'm curious. Huh. Okay. That's the second thing I've learned today. And I've already forgotten what the first thing was. Mod 3. What do we got? Complete this use statement. Oh, this is just system time? Okay. You can use the use keyword to bring in module paths, bring in system time and use epoch, and I know that's in standard time because I've done this before for all my advent of code stuff. Unix. Come on. Epoch. Like that. Yeah. Helps having a little experience, I guess. Shrishak says super probably means only the parent module can use it. Oh, okay. Yeah, I will definitely take a look at that. That's a neat way of limiting the scope of modules. All right, so now we're in Hashmaps 1. Okay. To do, declare your hash map here. To do, put more fruits in your basket here. Basket of fruits in the form of a hash map needs to be defined. Key represents the name of the fruit, and the value represents how many of that particular fruit is in the basket. You have to put at least 3 different types of fruits in the basket, and the total count of all the fruits should be at least 5. Okay, so we're just going to create a hash map here. Right? And then we're going to put more. I think if I run this now, it should at least compile. Right, and at least 5 fruits and at least 3 types of fruits both fail. So we need, let's just copy these, and we need 5, right? And if I do this now, it's going to pass the first test, right? At least 5 fruits. Oh, at least 5 fruits. Yeah, so I can apple, grape. What's another good fruit? We had pears, and just to be silly, we'll do a fruit / veggie. All right, so we have those. That's pretty easy. I guess we're learning how to do inserts. Mango, yes, mango. That's a good one. All right, hash 2. A basket of fruits in the form of a hash map is given. I'm not a fan of this passive voice here. The key represents the name of the fruit, and the value represents how many of that particular fruit is in the basket. Okay, just like last time. You have to put more than 11 fruits in the basket. 3 types of fruits are already... Oh, there's mango right there. I'm not familiar with lychee. Already given it in the basket. You are not allowed to insert any more of these fruits. Make the tests pass. Oh, I see. Now we have specific fruit types instead of random strings. So for fruit and fruit kinds, to do, put new fruits if not already present. Note that you're not allowed to put any type of fruit that's already present. Okay, so we can do if basket contains key fruit. Then we can say insert some. Basket, insert fruit 5. I guess. We could also try using the entry API. Right? Or there's also an insert get or insert, something like that. Find or insert. Contains key is what I just used. There's the entry API. There's insert. I thought there was like an insert or try insert. Shishak says lychee is a juicy fruit found in Asia. Drawback lychee is its huge seed. Oh, I'm looking for a thing that starts from entry. Okay. So entry has its own and modify or default or insert. So I could just do that, right? Basket, entry, fruit, or insert 5. Nope. Yep. Okay. Yeah, that was it. Yeah, I try to use the entry API whenever I can. All right, what's next? Hashmaps 3. And now the code compiles, but the tests fail. Okay. Hash 3. Here we go. A list of scores, 1 per line of a soccer match, is given. Each is of the form Team 1 name, T2 name, Team 1 goals, Team 2 goals. Example, England, France 4-2, England scored 4, France 2. You have to build a scores table containing the name of the team, goals the team scored, and goals the team conceded. One approach to build the scores table is to use a hash map. The solution is partially written to use a hash map, complete it to pass the test, make them pass the test. Okay. To do, populate the scores table with the details extracted from the current line. Keep in mind that goals scored by Team 1 will be a number of goals conceded from Team 2, and similarly, goals scored by Team 2 will be the number of goals conceded by Team 1. Okay, so I think what we need to do here is we need to do like an insert, or we have to insert or add an existing, So maybe it makes sense to write a function to do this, right? Update. Insert or update. Because I don't want to write it for Team 1 and also for Team 2. And so this will take a mutable reference to a hash map. Trishak says you can do that. There's an API in Hashmap. Right. Well, I mean, we have and modify, right? Provides an in-place mutable access to an occupied entry before any inserts into the hash map. Or insert. Right. So I can do this, but I only want to do it once. Right. Well, let me write it just for Team 1, and then maybe, so I can say scores dot entry Team 1 name or insert, and it looks like we're just inserting the team here, so it would be a team of Team one name. And we probably have to clone it. Goals scored is team 1 score, and goals conceded is team 2 score, right? And then we can say and modify. Oh no, this has to be zeros, right? Because we're doing and modify, right? So we're going to do an insert. Oh, I see. And modify comes first. Okay. That makes sense. And modify. And it's a closure, right? Yeah. Entry. And we can say e.goals scored plus equals team 1 score, and e.goals conceded plus equals team 2 score. Dot or insert. This has to be braced, right? Yeah. Oh, and modify unknown field. Oh, the entry is like this, right? Oh, what I was doing there, okay. Kafka says, or insert default plus equals score. Or insert returns a mutable reference to the value. Oh, yeah, so if I did an or insert and put zeros here, right? And then I could modify it this way. Okay, I'm still not, okay, because team 2 name. Yeah, see, this is what I wanted to avoid, was writing all of this code twice. Let me make a function which does the update here. Update scores. And we take a scores, which is unmute, hashmap, string team, and then we have name. Yeah, name is going to be a string. Goals scored is U8, and goals conceded is U8. Okay, so now let's see if we can do this the right way. Using the, so I'll do scores, entry, name, and now we're saying or insert default. Now there is no default for this, right? Because we can't insert default, but we can say or insert team named name. Now we're getting a little fancy here. Team named string self is self name goals scored 0, goals conceded 0, and I was trying to get a little sloppy and let the formatter help format things, but apparently that's still not good. Oh, it's because name is an ampersand string? No. Oh, because I didn't let it finish down here. Okay. There we go. I think this does need to be this, though. Oh, typoed something there. Sklurs. Okay. So now this should return. Kafka says that this should give me a mutable reference. So we could say and modify. And we could just say these lines here. Right? And then we can just say update score, team 1 name, team 1 score, team 2 score. And then the opposite. Like that. No, that blew up. What do we got? Okay, so the first one is help a function with a similar name exists. So obviously I'm update scores. Okay. And then name does need to be two-stringed. Okay. Expected 4 arguments. Oh, because I'm not passing the scores. Duh. Oops. And we're getting closer. We just need to pass in references here. Come on. And then this needs to be mutable, right? Expected mutable reference. And we're getting closer. And we're getting even closer. What do we got? Expected string found string. Oh. Can I deref it like that? Yes. And then and modify. Method is not found in mute team. Oh, so I can't do it quite this way. Because this is returning a mutable reference to this, not to the hash map. I can say let mot team equals this though, right? And then just say team goals scored. Right? Move occurs. And I can't do this because then it's going to complain, right? I don't know. Maybe it'll work because I'm using it here and then I'm using it here. So I don't think it'll... Let's find out. Oh, now it's expecting an ampersand string. Wow. Yeah. So I'm moving it here and then borrowing it here. So I can't do that. That's a little frustrating. Always clone your way out of it. That's a little ugly, actually. That's a shame. Can we do a match instead? Match scores entry name clone. There should be a way. Mouse access calling clone is the solution. Yeah. toString is cloning anyways. Yeah, up here when we're cloning it there. I guess. Yeah, I don't know. The other thing I was thinking, and maybe this would be too crazy, would be to create a trait updater, which takes in a update scores, which takes a, and then we have name string scored U8 unseated U8, and doesn't return anything, and then we can just impl updater for hashmap string team, right? It would just be this, which is essentially the same thing, except down here we would say scores dot update scores, right? I'm missing chat because I'm looking here. So MouseX says, I don't get why you can't pass ampersand name in the entry call. Yeah, it's expecting this exact same type. So it has to be the same type. If I take this out and put an ampersand name, then it's saying expected struct string found ampersand string. So it found a reference to string, and it even says take it out. Hashmap should be able to work with references to the key type. Kafka says not if you need to create a new key value pair. Yeah, because it has to create. If it's going to create it, it's got to find it, right? There's an or insert with. Oh, so I could just do this, right? But or insert with returns the value also. It doesn't return, it doesn't allow you to chain the entry. Or insert with key. Huh. And that also returns a mutable reference to the value. With key. MouseX says I should be able to just do this. It's got to pass the name in, right? Oh. Yeah, got to fix that. But this should be... Huh. That's pretty neat. That is pretty neat. Thank you, MouseX. So it must be using this name here, right? To pass into here. And that way I don't have to clone it. MouseX says the function only has one argument and the type matches. Are those the bounds for doing this? It has to have one argument and the type has to match the entry. That's pretty neat. How do you write this? If I wanted to write something like that myself, you just make it an FN once, and Rust will do it for you. ToString is still cloning the string, right? But up here, right? I don't have to clone it here and then clone it again through the team creation call. So that's good. Shishak says, yes, so you can even pass a closure instead of creating a name function here. Well, I mean, the insert with key, right, can take a closure, but then I'd have to put that closure in there, right? If I did it with a closure. Like that. Right. And then we can simplify, because it has one argument and the type matches, we can just simplify it like that. I like this. This is really cool. All right. So I've learned 3 things today. And I've already forgotten the first 2. All right, we're done. I think I was overconfident when I thought I could get through all 92 in one sitting. All right, so we're in quiz 2. This is a quiz for the following section: strings, vex, move semantics, modules, and enums. Let's build a little machine in the form of a function. As input, we're going to give it a list of strings and commands. These commands determine what action is going to be applied to the string. It can either be uppercase the string, trim the string, append bar to the string a specified amount of times. The exact form of this will be the input is going to be a vector of a 2-length tuple. The first element is the string, the second one is the command. The output element is going to be a vector of strings. Okay, so here's my module. And there's a bunch of to-dos. Complete the function signature. All right. So this is going to be a vec of tuples, which is going to be, right, because I'm looking here, it says string and command. So this is going to be vec, string, command. And it's going to return a vector. The output element is going to be a vector of strings. So vec string. Okay, done. Complete the output declaration. This is just going to be a vector of strings. Done. Now complete the function body. You can do it. Okay, so we're going to match on command. And it's either going to be command.uppercase, in which case we're going to do an output.push string to uppercase. It's going to be a command trim, in which case it's going to be output push string trim. And then we have command append count. Append bar to the string a specified amount of times. Can I do output dot? I can do output dot push format bang string and then bar dot repeat count, and then to do. What do we have to do to import transformer in scope? Super my module transformer, right? Is that it? And then we find out what I messed up. Oh. No, I have... Oh, this has to be a tuple. And this doesn't work. Oh, I have to string it. I can't just trim the... Yeah, so these are all strings. And then it's asserting these things are equal. Okay. So I have to, I can't just use trim directly. I have to do... This is saying help, try using conversion method to string. Oh, is trim returning a stir? Okay. Or we can do this. Can we? Why is this wrapping here? Oh, this expression has come in. Oh, yeah. So you can't do that. So I can deref it this way. Trishak was talking about the second one. She's public super. I don't know the first one because I grabbed quite late. I'm not sure what you're referring to. I mean, this does the trick. This is a pretty straightforward quiz, right? So, I think we're good. Finished quiz 2, which means I don't know how many quizzes there are. I'm going to take a quick peek how many quizzes there are. Exercises. There's only 3 quizzes. Okay. So does that mean we're 2/3 of the way through? Oh, I see. Here's a whole list of... Oh, we're going to get into lifetimes. That's going to be fun. That's where I'm going to fall down completely. All right. Options 1. You can modify anything except for this function signature. Okay? This function returns how much ice cream there is left in the fridge. If it's before 10 p.m., there's 5 pieces left. At 10 p.m., someone eats them all. So there'll be no more left. To do, return an option. Use a 24-hour system here, so 10 p.m. is a value of 22. Oh. Okay. So maybe ice cream is pretty straightforward, right? If time of day is less than 10 p.m., then we're going to return some 5. Else we're going to return none. And there's another to-do down here. Fix this test. How do you get at the value contained in the option? Yeah, I can just do it. Oops. I could just do an unwrap. I was thinking, well, what if it's not? But it should be because it's passing in at 12. So it should work. Okay. Very good. Next up is options 2. Make this an if-let statement whose value is some type. Okay. To do, make this a while-let statement. I think that's all they're looking for here, right? This is like an intro to options. Oops. What? You can stack option T and intos while let and if let. Oh, this is pushing on optional integers. Oh, okay. I didn't read the code. I should have read the code. Okay. Next, options 3. Oops. Don't do that. I'm not done. Struct point. Option point is some point. Match some point. Coordinates are blah. No match. Fix without deleting this line. Oh. Okay. Yeah, we're just creating a reference to it. I think that's all they want to do, right? Oh, the compiler showed that. I didn't even look. Let me see what the compiler says the solution is here. Oh, we can just do a ref p inside. Yeah. That works. This is something that it's not in my immediate brain. You know, I stuck an ampersand there, just make the whole thing ref. But we can do a ref inside the match. Trishak says, thanks to NLL, that ampersand Y works. And what's an NLL? Errors 1. Is that somebody who contributes to Rustling? We don't see any to-dos. Expect an option. So line 28 is our first failure here. Generate name tag text. NLL stands for non-lexical lifetimes. Okay. That's something I don't know yet about Rust. So, that'll be something else to look up. Let me make a little note. Okay. Thank you. I will have to take a look for that. So this is doing an OK and error. Okay, this function refuses to generate text to be printed on name tag if you pass it an empty string. It'd be nicer if it explained what the problem was instead of just returning sometimes returning none. Thankfully, Rust has a similar construct to option that can be used. Let's use it. So I think we're just looking for a result type. And we can just say error here. Name was empty. It must be non-empty. I guess we can make this a stir, right? And this should be okay. Nope. Oh, we can't make it a stir, but we can make it a string. No, failed. Explains. Oh, I forgot to gotta add the full stop. Here we go. Okay, next is errors 2. Errors 2. Say we're writing a game where you can buy items with tokens. All items cost 5 tokens, and whenever you purchase items, there is a processing fee of 1 token. Okay. A player of the game will type in how many items they want to buy, and the total cost function will calculate the total number of tokens. Since the player typed in a quantity, though, we get it as a string, and they might have typed anything, not just numbers. Right now, this function isn't handling the error case at all, and isn't handling success case properly either. What we want to do is, if we call the parser function on a string that is not a number, that function will return a parse error, and in that case, we want to immediately return that error from our function, and not try to multiply then add. There are at least 2 ways to implement this that are both correct, but one is a lot shorter. So I think we can just question mark the parse, right? But then they said that the isn't handling the success case properly either. All right, let's find out what that is. Oh, okay. It was just a question mark. I must be misunderstanding what they mean by can't handle the success case. Error 3. This is a program that's trying to use a completed version of the total cost function from the previous exercise. It's not working though. Why not? What should we do to fix it? Total cost. Oh, because it's checking here, the question mark, and the function doesn't return an error. I mean, we can just expect value. Input is not a number. right? We could just expect it. I don't know if they're looking for something else or if I should modify the return function. If other functions can return a result, why shouldn't main? It's a fairly common convention to return something like error type from your main function. Unit type is there because nothing is really needed in terms of positive results. So we could do it this way then as well. But I think this is probably a little uglier in terms of the output. And that failed. Oh. Huh. Oh, and then we have to return it here. Right. Either way. Yeah, Sri Shak, sorry, I wasn't paying attention, but yeah, that was exactly it. Okay. Errors 4. Why is this only returning an okay value? Oh, okay, so we're just checking. Oops. We can do this. If value is less than value is less than 0, error, creation, error, negative. Else, if value is equal to 0, error, creation, error, positive. Else. And actually we should do this with a match, right? Oh, this should be 0. Yeah, we should be doing this with a match. I don't know if they're going to talk about that at some point. And if n is less than 0, 0, and everything else. Right? Is that better? I think that's cleaner. That looks nicer. Looks a lot nicer. All right, but we haven't been taught this yet, so I don't know. I don't know if that's something that's coming up in a future lesson. This program uses an altered version of the code for errors 4. This exercise uses concepts we won't get to until later in the course, like box and the from trait. It's not important to understand them in detail right now, but you can read ahead if you like. See, I did a GQ and it's still not wide enough. In short, this particular use case for the boxes is for when you want to own a value and you care only that is the type which implements a particular trait. To do so, the box is declared as of type box din trait, where trait is the trait the compiler looks for on any value used in that context. For this exercise, that context is the potential errors which can be returned in a result. What can we use to describe both errors? In other words, is there a trait which both errors implement? So we're looking to replace the triple question mark. We have standard error, we have standard format, we have standard num parse int error. Update the return value of type main to make this compile. So pretend user input returns, the parse returns the parse int error. And this returns an error that we had from before. Oh. They did x if x equals 0, and then just x for everything else. Yeah. I guess I was being. I mean this. Okay. Well, Shrishak has the answer. It's standard error. Okay. Gotta type it right. There we go. Okay. So they're just teaching how din works, I guess. Here's error 6. Using catch-all error types like box-in error isn't recommended for library code, where callers might want to make decisions based on the error content instead of printing it out or propagating it further. Here we define a custom error type to make it possible for callers to decide what to do next when our function returns an error. So we have a parse pause non-zero error. Oh, I see. So we're just wrapping the error this way. Add another error conversion function here from parseInt. Oops. Gotta spell it right. Parse. Wow. Pause. Non-zero. Error. Parse int. Sometimes my keys get away from me here. Error. Okay, and then parse pause non-zero to do changes to return an appropriate error instead of panicking when parse returns an error. So that's just question marking it, right? Wait, no, we can't just question mark it because we want to convert it. So we can do the same thing here, right? Map error. Come on. Map error. Parse pause non-zero error from parse int. And this looks like this is the same kind of thing where we're passing the function, takes one argument, and it maps. So we don't have to do anything else. Don't change anything below this line. No, because I misspelled it. And it still doesn't like it. Expect it found, question mark, right? Yeah, okay. Very good. We're getting there. 55 out of 92. Okay, and line 9, expected identifier. Generics 1. Just use your knowledge of generics to fix it. I mean, my knowledge of generics is we can do type inference. Right? So why even put that there at all? But I guess we can do stir. Right? Isn't that the type? Yeah. Okay, we have generics 2. This powerful wrapper provides the ability to store a positive integer value. We write it using generic so it reports wrapping any type. So, not good with the syntax here. Is it this? And then we say impl t, t, t. Right? Oh, good. Okay. I did remember the syntax properly. All right. Next is traits 1. Time to implement some traits. Your task is to implement the trait append bar for the type string. The trait append bar has only one function, which appends a bar to any object implementing this trait. This should be like this, right? Okay. So we just need to implement this append bar self, returning a self, and this is for string, so we can just say format self bar. That's all we need to do. Nope, they both failed. Oh, it has to be, okay, I misread it. No space and a capital B. One sec, text from my wife, yes. All right, that's that. Isn't there a push bar? But this is non-mutable, right? This has to be mutable. Expected string found something. Yeah, cannot borrow is mutable. And I have to change the function signature here, right? Patterns aren't allowed in functions without bodies. I didn't realize that was called a pattern. Expected a string because of return type. Isn't self pen bar can't borrow is mutable. Yeah, so I think we have to just create a new string like this. Yeah. All right, let's see what traits 2 is all about. Your task is to implement this trait append bar for vector of strings. To implement this trait, consider for a moment what it means to append a bar to a vector of strings. No boilerplate code this time, you can do this. Oh, okay, we're just going to push. Here's where we want to push, right? And we're returning a vector of strings. This is a vec string. And again, we don't have a mutable reference to self. So do we need to create a new vector? Oh. Yeah. Yeah. Well, I guess that's the way we do it. Okay, traits 3. Here's a licensed trait. Licensing info, some software, other software. Don't edit these lines. Okay. What do I need to do then? Your task is to implement the licensed trait for both structures and have them return the same information without writing the same function twice. Consider what you can add to the licensed trait. So this is, okay, so is this where we're going to, but we need to write licensing info. How do I write, if I don't edit this line, how do I add a, an impl for licensing info? Yeah, so I do need to edit this line, right? Yeah, so licensing info is going to return a string. If we implement it for some software, I think I need to edit this line, right? Consider what you can add to the licensed trait. Can I add something here? I thought I just have to implement licensing info. Oh, you're saying yeah, so I can edit this, right? But it needs to be able to say, oh, I guess what I can do is say self get version as string, right? But then I'd have to implement that. Impl some software get version as string format bang self version number, right? And then we can just do that for impl other software, and this just returns self version number. Is that what they're looking for? I might have to clone it. Oh, I forgot to add the self. Duh. So I can do this. Get version as string self. Oh yeah, but this is implementing licensed. And I have to edit this line. So I'm missing something here. Unless I do this, right? Versionable trait versionable like that. Nope, can't leave private trait. I'm leaking a private trait. Versionable is declared as private. Right, is some information. Wait, what's going on? Oh wait, this is supposed to be some information? Oh, I misread what needs to be happening here. All we need to do is be returning some information. Okay. I totally misunderstood. So this is just some information to string. So we don't need this, we don't need this, we don't need this. I thought we had to return the version number. I thought I was going off the deep end there. Oh, semicolon. Okay, so it was simpler than I thought. I didn't read the tests correctly. All right. All right, what's next? Traits 4. Your task is to replace the question mark section so the code compiles. Don't change any line other than 21. 21. This is line 21. Maybe they mean line 22? Okay, traits 4. Line 21, 22. Okay, software licensing info is equal to software 2 licensing info. So this is just licensed. Is that all we're looking for here? Oh, boom. Oh, DIN licensed. Can it infer the lifetimes? Oh. What do we got? Expected DIN license found struct some software. Help considering borrowing here. I'm not allowed to change line 35 though. Oops. Shrishak says T-call license. Are we doing what? Oh, do we not need the ampersand? I thought we would for DINs. Oh, gotta undo this thing here. No. Okay, so I guess I don't understand what they're going for here. I mean, I could put a type in here. Like this. Oh, they have to be two separate, they're two different types. Yeah, okay, that was it, Shrishak, thank you. I thought I could just put it here, but I guess not. Can I do it that way? Let's find out. Yeah, it doesn't like that at all. They actually have to be specified as generic types. That's good to know. All right, next up is traits 5. Your task is to replace the question mark section so the code compiles. Don't change any line other than 27. 27. It should be 28. Oh, impl licensed. Oh, let's try it. Yeah, that's it. Okay, so either one of those will work. And this is a little bit shorter, I guess. This way. Thanks, Kafka. All right. What else we got? So traits 5, right? So 28, we're going to change this. Item some function, item other function. They both are bools, and they both are traits. This implements both traits. So this is where we can just say don't change any line other than 27. This has to be able to some trait plus other trait. Do I have to put impl? Or do I put the type thing in there with the plus? Yeah. Okay. Good enough. What's next? Yeah, Epic Blog says off by 1 errors in Rustlings. Yeah, probably they just added some extra text or something like that and forgot to update the whatever. Quiz 3. Wait. We're only on 64 of 92 and we're on the final quiz. This quiz tests generics and traits. An imaginary magical school has a new report card generation system written in Rust. Currently, is that the only? Oh, exclamation mark. Currently, the system only supports creating report cards where the student's grade is represented numerically. However, the school also issues alphabetical grades and needs to be able to print both types of report cards. Make the necessary code changes in the Struct report card and the impl block to support alphabetical report cards. Change the grade in the second test to A+ to show that your changes allow alphabetical grades. Okay, so is there a to-do or a chiroptical? Thank you for the raid. Thanks for stopping by. How was your stream? Have you been doing Rust lately? I've dropped in, peeked in a couple of your streams, but they tend to not be rusty, so I just kind of have them on in the background. Tom Riggle and Gary Plotter. I don't know what these are references to. Optical says I just finished property testing merge sort. Oh, properly testing a merge sort in Rust? Yeah, merge sorts are fun. Trying to remember the last time I wrote one though. It's been a while. Yeah, I mean, typically these days you just use standard library stuff for that. But it's a good learning tool. Okay, so I need to make code changes in the Struct report card and the impl block to support alphabetical report cards. So I need to be able to support, so we have the grade as an F32, which is 1.0 to 5.5. 1.0 is an F- and 5.5 is A+. How's the test run here? Grade 2.1. Make sure to change the grade here after you finish the exercise. Oh, so I'm going to change it to, okay. I see, but it doesn't really say. How do I make it equal to, because we're calling the print function, right? It says generate numeric report card. Oh, okay. So maybe we're going to just modify this. Pub as I am working on. Chiroptical says, what are you working on? I'm working on Rustlings. Rustlings is a tutorial sort of test suite sort of for Rust. And they just released 5.0.0 and I had never gone through all of Rustlings before. I mean, I started it a couple of years back when I first started getting into Rust. But I never really went through it. So now I decided, well, let's give it a shot on stream and see how badly I can fail. So this is as string. Cool. And then print can just, how are we testing generics though and traits? Because all I'm doing, so I'm not doing anything with generics or traits. And I should, right? because I can just do an if here, right? Self as string. Oh, maybe I can make the grade. Right, I can just say self student name as letter. And then I can just implement a trait as letter. And then I could say impl as letter for F32. Does match allow? I know it allows ranges, but does it allow ranges for floats? Car Optical says, have you ever done exorcism? I have not. I don't even know what that is. Develop fluency in 59 programming languages. No, I have not. I have not tried this. But this looks like another, like a code, leak code kind of thing, maybe. Shrishak says, cannot you change the scoring to generic so that it can represent both F32 as well as a string? That's a good idea. I like that approach. Shrishak says, when we change the score to generics, the trait will also require generics. I don't know if the question wants that. King440 says, hello. Hello, King. Yeah. So if I make this grade a type that allows you to choose what to print. Car Optical says the only difference is that it has mentors, which is neat. I'm mostly curious if you would comparison, but no worries. Yeah, I haven't used it. I haven't heard of it, but I don't know. I have a kid who wants to learn how to program, so maybe this would be a good option for them. So if I make the grade, yeah, but I'd have to say, all right, let me see if I can get this one working, right? Because this is basically, now we want to compare. Let's see, 1.0. Can you do this in? Can I do into? And then everything else is just A+. Just to see it. Is this going to work? Because yeah, you have to do exact, right, for match ranges, and you can't really do that for. I missed a format here. Missing S string. Is this going to work? Yeah, so this works, but this isn't really. I don't think it's meeting the spirit of the exam. Let's see what they say for hint. Find the best solution to this challenge. You're going to need think back to your knowledge of traits, specifically trait-bound syntax. You also might want standard format display. King says, "Wait, you can define implementation from any file. You have to have one or the other defined in the same file. I can do as letter for F32 because I'm creating as letter here, but I can't do U32 for F32. Oh, because it's not a trait. Can't think of a trait option. not a trait. If you've defined the trait, then you can create anything. You can attach it to anything that you want. Display as a trait. Yeah, but it's probably already defined. Cannot find display in the scope. There's another error that I've seen before, because I've gotten it, where it says that you can't define this trait for that trait. TreeShack says you can implement it as long as you have types or traits in your crate. It's called orphan rule in Rust. Rust orphan rule workaround. Allows writing a trait impl only if either your crate defines a trait or defines one of the types the impl is for. Right. It means if your code uses a type defined outside your crate without a SERDI impl. Oh, this is probably relating to SERDI then. You resort to new type wrappers or other obnoxious workarounds for serializing it. Optical says you have to enable orphans in Haskell. It isn't allowed by default. Okay. I've tried Haskell, and I'm not smart enough for Haskell. So I stopped. There's a guy who does Advent of Code in Haskell. Alan Malloy. So I've watched his streams, and I feel like I learned, but then you sit down and say, okay, I want to write something in Haskell, and I just get a blank. King says, I don't understand what for is. For is just a keyword to say I want to what you're implementing the trait for. Normally, if you do an impl on a type, on a struct, you don't need the for, because you're not implementing the trait for a type. Like I can also say impl as letter for report card, right? And then I have to write an as letter for it. And then this self becomes a report card. Here the self is an F32. Here it's a report card, right? And it has to return a string because it has to match the same function signature as in the trait. And then I don't know what this would return. Right? We could format this as a debug output. Right? We're not using it. What's impl report card doing? It's just printing out so it didn't used to look like this. It used to just be this one line here. And what I'm doing now is having it so that it prints out, to make the test run, I'm having it print out the A+. But I think they want more. The problem is I don't like this because this is going from 0 to 1, right? And then what do you do here? I can't say 1.0 to, I don't know, what would be the next letter grade? I'm not going to put every letter grade in here. 1.5 would be an F into, but now these overlap, right? These two ranges overlap. So I imagine that'll blow up. Yeah, exclusive range patterns. Oh, sorry. So maybe that's why I want the exclusive range pattern. Oh, it works. Really? Five 5.5 is A+. And of course, I want to have something else. Yeah. So now I've fixed this, and now I change my report card here to 5.5. It says because change the grade here after you finish the exercise, and now I have it. So I'm not using generics. I guess one of the things that TreeShack says we could just make this grade a generic, right? Have the grade be a type. And then when we implement report card, we'd have to have that type. But would that even work? Because you wouldn't need... So you have the type there, but then what would you put here? Because we're not using it. Right? We need the generic argument, but... Okay, so we can do it this way, right? We can have a trait grade as letter or as a number, and then have it convert between the two. And then we have as letter for F32 and as grade. For F32 we have it as letter, and then I have as number, self, which also returns a string. We could do it as display, like they're suggesting here. Oops. Right? And this would just be format bang self, because it's already an F32. Doesn't like any of that. Oh, maybe like that. Oh, I forgot the thing here. This is a grade. Wait, no, you don't put anything here, right? And it's still not. Oh, method not found in T. Oh, yeah. So it has to implement grade. And it doesn't like that. Associated type bounds are unstable. The struct takes one generic argument, but 0 generic arguments were supplied. It's saying put a T comma in front. Thanks for stopping by, Car Optical. Yeah, I should be going to work too. Associated type not allowed here. You put the colon grade in the first T, not the second T. Okay. See, I'm learning. I'm definitely learning, right? Oh, it still doesn't like that. It doesn't have a size known. So you can't return a display, but you can return a string. This might be the easiest way around this. And then I'm gonna have to put as number for one of them, right? It's suggesting I put a display on there. Oh, because I gotta say to as number. There. Okay. So we have traits and we have generics now. Thanks to everybody's help in chat. All right, so we got 63 out of 92. That's 2/3 of the way there. That's a good stopping point, and then maybe tomorrow I can finish these up, because these are taking longer and longer now, right? as one might expect. Let me just take a quick peek at what the next one is, and then we'll start there tomorrow. Tests 1. Oops. Oh, these are going to be easy. Okay, so we'll start there tomorrow. Maybe the first few will be easy, and then they'll get harder. All right, thanks for hanging out with me. I really appreciate you being here on the stream, everybody, and I will see you tomorrow. Have a great day, and take care.